Continuing on, we've got geometric sequences. So we're back to sequences, which is a list of numbers, you can see here, with commas in between. We're not adding anything, we're not summing anything up. That's a series. We are just dealing with a list of numbers. But it doesn't involve arithmetic anymore. It involves geometric? I don't know what that is. So let's take a look. A geometric sequence is a sequence of numbers derived by the multiplication. Ooh, that's really important. So we're no longer going to be doing addition, we're going to be doing multiplication. Or, and here's a weird thing, when you can do like timesing by 3. That's multiplication. Okay? But you can also do timesing by a third, which is the same thing as dividing by 3. So when it says multiplication, you can also have or division, just depending on in which direction you're going. So it's multiplication rather than addition. So it can be generated by getting to the next term is going to be generated by a multiplying. Now we don't call that D anymore. It's not a common difference. Instead we've got a common R or a common ratio. Common ratio, yeah. So are these geometric? So what does it take to go from 2 to 10? Well, from 2 to 10, I am timesing by 5, and then from 10 to 50, I'm also timesing by 5. So my R is 5. It matches. So yes, are these sequences geometric? What is the common ratio? So my R is 5. Yes, it's geometric. So I'm just going to put yes. Now here, what does it look like we're doing? Well, looks like we are, I don't know, this one's adding 10. And then from here to here, you're adding 100. So that's not a common thing. So you think, okay, well maybe you're timesing it by 11. So 1 times 11 is 11. But then from here, if you times that by 11, 11 times 11 is 121. So you're not timesing by 11 either. So the idea here is, yes, there's a pattern, but there's no common ratio. So this is definitely a no. There's no common ratio. Okay. What about this? Okay, so from here to here, I'm dividing by 2. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 divided by 2 is 3 divided by 2, 3 over 2. So yes, we are dividing by 2 every single time. So R is, and we don't say 2, we say a half, because you're timesing by a half. Same thing as dividing by 2. Now, how do you actually remember that? Well, you can always do what we did last time. Remember, we go one term minus the previous. Here, it's one term divided by. So 6 divided by 12. And those can both be divided by 6, and so you end up getting a half. So your common ratio, you're timesing by half. So yeah, it's not even very accurate here for me to put dividing by 2. A more accurate statement, even though I was dividing by 2, was that we were timesing by a half every single time. Okay, so yes, it does have a common ratio because it's being divided by 2 every single one, or timesing by half. Okay, is this geometric? So from here, from the first, I guess I'm timesing by 1. 1 times 1 is 1, and then I'm timesing by 2. 1 times 2 is 2, and from here, I don't even know. I think I'm timesing by 3 over 2, but that doesn't make any, like that's not the same. It already doesn't, it's already messed up here. The fact that they're not common numbers. So there actually is a pattern here. It's weird, but if you have 1 and 1, 1 and 1 gets you 2. 2 and 1 gets you 3. 2 and 3 gets you 5. 3 and 5 gets you 8. So every number is made up of the previous 2 numbers being added. But that doesn't matter. No, it is not geometric. How do you prove that? Pick any 2 numbers and divide them, like 2 consecutive. So 1 over 1 is 1. Pick these ones, 8 over 5. Well, I can tell you it's not 1. So that immediately proves that it's not a common ratio between them. Okay, how about this? 3, so negative 12 divided by 3, which would be a negative 4. Okay, so I'm timesing here by negative 4 to go from there to there. How about from here to here? I'm also timesing by negative 4. Negative 12 times negative 4 is positive 48. Nice. And timesing by negative 4, 48, 48, 48, yeah, negative 192. A positive 48 times a negative 4 is a negative 192. Okay, so yes, it is geometric, and the common ratio is negative 4. Okay, so I just zoomed out here in case you need to pause anything, though it is just printed on the PDF, so you can take a look at that. So 2 of them were not geometric because they didn't have a common ratio between them. Here, the common ratio, we were timesing by negative 4. Here, the common ratio is we were timesing by a half, though really to figure it out, we were dividing by 2, but the ratio is not 2. It is a half. And then here, the ratio was timesing by 5. Okay, so a geometric sequence can be written like this. So we have our first term, and then we have our first term times our r. And here we have our first term times r, 2 r's. Then we have our first term times 3 r's. And that's what happens. Every single time we just times by another r. 3 r's, 4 r's, 5 r's. Now, that's kind of whatever, but it just allows us to write this formula. So if we want to find any term, like say I want to find the 50th term, then I'm going to take your first term and then times it by as many r's as you need. And in this case, it's always going to be r to the n minus 1. So if we're looking for the 50th term, this would be 50 minus 1, 49. So we're going to have our first term times 49 different r's. Sorry, all the r's are the same, but 49 r's. So that is the formula, and we're going to use that formula in the next video. Now for this, unlike anything else we've really done, we are going to be using a calculator just to make things way more convenient, because when we're adding d's in the previous arithmetic section, we can add d's. There's so many of them, but it is possible. But r's, when we're timesing by r, multiplying things 30 times, that can get very tedious. So we are going to use a calculator. So keep that in mind. But we'll do that in the next video.